Welcome everyone to our third Serious Games for Climate Change showcase. So we're now on our third year that we've been doing this, and I'm excited to share with you because a lot of our projects now have really matured to a level I never imagined they'd reach. And so all of you that are here, you'll get to hear from all of the students throughout the next hour, and we will be presenting on all the projects that we've been developing, and then afterwards we'll get some food, and then there'll be time for you to check out all the demos for all of the projects that we're doing. So let's go ahead and jump in. So like I mentioned, this is our third annual showcase. This was actually our first showcase that we had. And a lot of the projects that you will see today started all the way back 3 years ago. So one of the really nice things about the AIP program is that we're always building on top of the work that students have done in the past. So we have this transfer of knowledge, this development and growth in the program every year. And just to give you a little background on the AIP program, for those of you that don't know, so really my goal in the Serious Games for Climate Games project is to really give students a unique opportunity to enjoy working in teams, developing real-world applicable projects for the real world. And what better topic to focus on than climate change? And so over this year alone, we've had more than 30 students that have participated in the program. And we've had 5 projects that we've been working on over the year. Students are given 12 units of credit, so you can take this class 3 times throughout the year. So unlike most other classes, you get this consistency and you get to take what maybe you just started to learn your first quarter into the winter and spring quarter. And then for many of you, one of the other nice things is that we have weekly meetings where you get to get almost one-on-one with specialist faculty here at UCSD. And this is another unique thing that you're really not going to get in any other program. And then finally, the last thing is that we have many students here that will present that have actually been with me for more than a year. They've been with me for 2 years, some of them even 2.5, almost 3 years. And this has allowed them to really grow in not only learning all of these skills, but also learning how to be leaders and how to lead teams. And so usually what I do is those of you that have made it through the first year, if you're willing to come back the second year, I'll make you team leads to run your own team and your own project through the next year. I mentioned earlier that we have faculty and professors that pour into the students in the AIP program. And so that includes Tom Levy and myself, who are the co-directors of the Center for Cyber-Archaeology, as well as Yves Thoreau, Yvonne Gonzalez-Gamboa, Eric Veer, Gilad Steinberg, and Bernard Jackson. So all of these professors have been working with the students across these different projects. We also have lots of mentors and collaborators that also work with us. So we have Giovanni Vindiola, the applications programmer for QI, and he's really played a huge role in not only working very hard to fix and develop all of our different projects, but also he's really played a critical role in mentoring students as well. We also have Matthew Bracamontes. I don't know if I pronounced that right, Matt, but he's a staff research associate and has been working for the Center for Astrophysics and Space Science. So he's been working with a solar weather project you learn about shortly. And then we have Danny Vo, who actually was an undergraduate and a master's student graduate here and has been working as a volunteer. And he also is part of a new company that we actually formed together with Eric Veer and Jeffrey Belk that has 2 patents on its belt, and you'll learn more about Health VR in just a bit. So one thing that I've been actually getting a lot of questions about today was how do all these games fit together, or where was this game that I saw the year before? And really what we've been doing from the beginning is we've been creating what I call Cyber-Arc Core. So Cyber-Arc Core started with a project we call the Cyber-Arc Warehouse. And this project was all about archaeology and about how do we store archaeological data and to be able to retrieve it and visualize it. And then we started saying we don't want to just be able to access our data and visualize our data in 3D. We want to gamify it. And I'll talk a little bit more about that in a minute. And so about 2 years ago, we applied for a grant that got us funding to develop what we call climate games. And so this year, what we did is we started taking climate games and all of the game mechanics and started with avatars and dialogue and interactions, and we built them into the core of the game. So you actually see the same characters and the same interactions across all the games that sprout out of CyberArk core. And right now the games that really, I would say, are sprouting out of CyberArk core is Cognitive City Twins, Solar Weather, Nanoverse, and Health VR is really a supporting game that actually is going to help make all of these games better. And you'll learn about that today. And so I mentioned that one of our main goals this year was to integrate climate games into everything we do. That means gamifying all of the visualizations that you'll see today. And the main motivation behind this is that I strongly agree with these statistics that traditional ways of learning are quite boring, especially going to lectures. And I know today there'll probably one of you that will start to doze off as I talk, right? There's something about lectures that's boring, and you don't learn the same way. And we're not really meant to learn in just lectures. And so game-based learning is a way to bring back interaction, participation, and even more than that, when you play games, you can foster empathy. You can become emotionally invested in the game that you're playing. You can start to identify inwardly with the goals and visions that the games that you're playing. And ultimately it can lead to a passion that maybe if you play one of the games that we developed here, that you want to go into astrophysics, you want to go into becoming a marine biologist. Who knows what it may lead to. And so that's really one of the goals here, is that these games not only are just about learning, they're about developing an investment in what you're learning about to where you may want to take it and become and make that part of who you are in the future. And of course, with games, you have this feeling of just accomplishment. It also can build a self-esteem, and it's also reward-based. So these are the 5 games that we're working on this year. And I kind of like to put them under this category of digital twins at scale. And we'll talk a little bit about digital twins later, but you can see that we have games that are at different scales of the world. We have at the human scale, we're creating these what we call historic metahumans. And we're also trying to understand how humans interact inside VR with health VR. We have at the building scale. So some of you will get to see a demo of the W Hotel in Hollywood. This is just part of one city area that we're focusing on to create building scale digital twins. And also we're working on QI as well as others. And then we have city scale. So we're hoping to make city scale digital twins of UCSD, of Hollywood, and of Tel Dor in the Haifa region. And then we're going even all the way out to the solar scale with solar weather, where we're creating digital twins of our whole solar system. And then we're going all the way down to 1/1,000,000th of a millimeter to the nanoscale and creating digital twins of cells and how things work at the nanoscale. So with that, why don't we invite up the first group? And the first group is the climate games. So why not everyone that's worked on the climate games, why don't you come on up here and we can you guys can present on what you've been doing this year. The climate games, I'll just give a little brief intro to the climate games. Like I mentioned, climate games has now kind of become a central core to everything we're doing. And it really came out of the creating games for a class that was called Digital Documenting Climate Change with 7th College. And we created these different games, but one thing I realized is that it's really hard to create a game in 1 quarter. It's really hard to tell your story using Unreal Engine as an editor. And so we had the idea, what if we could actually, with my talented students, create a game that allows you to tell your story, allows you to be able to create the exact quest, the exact experience, but without having to learn Unreal Engine, which can take at least a year to learn. I think all of you would agree, but still be able to accomplish something amazing. And actually, we were awarded $50,000 to develop the climate games. Out of it, we actually decided to create a startup game studio called Resilient Studios, which is now here at the Qualcomm Innovation Space. And the goal of Resilient Studios is to provide another avenue to, one, allow students to be able to see what it's like in the real world when it comes to developing games, to allow students to get a first-hand experience in that, but also to create great games that can have an impact on our understanding of the climate and the environment. And I think I'll skip these two slides and just jump right into talking about letting Doris share some of the unique features that we added this year for climate games. And just to quickly introduce, Doris is the team lead for climate games. And so with that, I'll hand it over to you, Doris.
So I'm the team lead, and for this quarter, I've been mostly working on quest dialogue because the main part. Can I play the video?
Yeah.
Okay. Because the main part of climate games is being able to tell stories about climate change and about different problems around the world. And so one of those things would be creating dialogue that you can talk to NPCs and really feel a personal connection. So normally, if you want to create dialogue, you have to go into Unreal Engine and you have to go into the back and kind of work with blueprints and stuff. So I wanted to create like a more user-friendly within the game itself. We have a creative mode where, as you can see in the video, where we have a quest configuration and we can choose dialogue to create stories, basically. And here I'm just doing like a small basic demo of a joke kind of dialogue, and you can see I'm typing it in. And basically how it works is that we create dialogue trees using pieces, dialogue pieces and response pieces. So responses are for players to respond to, so it's more interactive as well. And yeah, you can see here in the editor, we have an editor to create dialogue, and we already have some pre-made ones. So this is joke one and joke one, response one. And here I'm just connecting them together like puzzle pieces, and then creating them and saving them into the quest. And as we go on, you can see that if we interact with the NPC now, we can see that it pops up on the chat on the right side, which is where we will be able to interact with the NPC and select whatever responses we want. And here we just have like, why did the chicken cross the road? And it's to get to the other side. And next, Julia was working on the farming simulator. She can't be here today, but her progress was basically creating farming like kind of in the creative mode. You can create these farming boxes and plant these plants in real life time or whatever time that the player wants, and have them like grow and turn into actual trees, like from seeds to trees in real time. And you can see here that she's placing them in these like planter boxes, and eventually they'll show that there's like a little progress bar showing them growing up, and this is all done with using like in the game itself, and you can do this as a player. Let's see. But yeah, you can see that these trees are just slowly growing over time.
All right.
Hi, my name is Jeffrey Hatza, and part of the Climate Games, I worked on the MetaHuman customization system. And so we have our different characters and our different player avatars in our games, but we want to be able to customize them through different means of changing their clothing, their hair, and their faces. And so in this video, you can see that I chose a preset male character, and we can change around the different assets of the face and also the hair, now the clothing as well. And so as we customize these characters, once we finish customizing them, we could be able to save them and use them for later by adding them. So you can see I name the character and I add it, and I'll add it to your list of preset user characters there. And that stores them onto a database called CouchDB, and that's linked to your player profile, which is linked to your Epic Games account. And so that we can use our player character that we customized in the game and change our character at any time using the UI. And some future work that we want to work on with this. Yeah. So some of the future work we want to work on with the customization system is to have the ability to switch between different body types for each of the genders, and also have a custom hairstyling system and clothing system to give players the ability to express themselves as their avatars or represent different characters they want to see in the levels that they make.
sorry. Hi everyone, my name is Anne, and I've been working on the character.
Be closer to the mic, please.
Oh, yes, okay. Hi everyone, my name is Anne, and I've been working on the color picker for character customization and for general use as well. So as of now, the color picker can be used to change the color of several meshes, like the shirts, sweaters, pants, and shoes in character selection mode. And then for future work, the color picker can also be used to change the color of the skin and hair when trying to add or edit a character. And here is some footage of that. And also thanks to everybody who has helped me this quarter. Yep.
Hello, I'm Shu Yang, and I work for the water and the sand dynamics for all this. There's an important system called the full flux system, and I use this system to implement the Sea of the Tel Dor, like the graph you can see, the wave, the coastline, and there will also be spin drift. I can also use this to work as a parting of the sea, like the.
This one?
This one, I think. Yeah. This is a scene like in the Prince of Egypt when Moses parting the sea, and you can see like the sea waters are flow upside down, and you can also hear the sound of the sea. This one. And also after that, we can simulate it to make the sea clumps together, and it will become the original sea again. And And for this, you can also change the sea levels for the Tel Dor, so it will show like the sea levels at different time of the Tel Dor. Yeah, like this. And for the sand dynamics, I work with the height map on the UE, and so that the character could have their footprint on the sand. We can use that for a desert or for the coastline. In the future, I want to finish the parting of the sea and integrate the sand dynamics with the climate change levels. I may also want to try to evacuate the sand under the sea.
My name's Ava Ntochi. I worked on the clothing for Climate Games. I joined pretty recently, so far what I've done is work on outfits depicting Shasu nomads. If you can see up there, I have tomb paintings from Egypt depicting Shasu nomads, and using this and also previous archaeological research provided by Neil, I was able to create clothing in Marvelous Designer, which can then be used in Unreal Engine. And yeah, my future work for the summer and next year is more outfits. This specific tomb painting, it also depicts multiple variations besides these two, as well as outfits for women. And yeah, this will later hopefully be implemented as like another option for character customization. So yeah, thank you.
Hello, my name is Kevin. I partially worked on the speech gesture control plugin. Basically, I was part of a team that does historic metahumans, where we link AI models to generate speech, audio speech, animation data for historical metahumans like Muhammad Gandhi. And so we decided to extend on our previous project to incorporate it into different kind of projects that we're doing, such as climate games. So basically the system, the SGC systems, like links the Unreal Engine with our external AI models to be able to enable intelligent metahumans in multiplayer gameplay. So there's this SGC plugin in the Unreal Engine where we can use it to request AI services in game for NPCs to animate generated outputs. And the AI models can also be launched locally or remotely through the SGC cloud on an Nautilus Kubernetes cluster. And so it's like more of a systematic pipeline that we can create intelligent NPC interactions. And so some of my future works are to finish implementing the SGC cloud, optimize the pipeline to more efficiently support multiple sessions and idle NPCs, and also refine AI models to extend more characters. This is a video demonstration of how it looks like.
Who are you?
Hi, I'm Tom Levy, an archaeologist. It's great to meet you. I'm currently standing in front of the site Tel Dor in Israel.
Tell me more about Tel Dor.
Tel Dor is an ancient city located in Israel, situated on the Mediterranean coast.
Yeah, so that was the demo. And I also was part of this side quest of Climate Games where we worked on Professor Video avatars. Basically, this side project is more on generating speech videos given a short input video. For example, if you want to play the original one. So for example, given this original video.
Martin. I'm Director of Media Services here at UC San Diego, and I'm here to record a training sample of my voice and likeness for testing with AI generation tools. For this content, I want to talk
and this is clear. She worked on training the text-to-speech model of these for like our professor videos.
Yeah, basically for part of like the pipeline to create the video avatars, we had to take like the audio from the original video and also the text transcript from the original video. So what I worked on is I kind of developed this pipeline. Sorry, let me just pause this real quick. Okay, so as part of like this project, I worked on developing like a Python pipeline to kind of extract like the text and the audio, and basically by having like that separate data, we're able to pass it through the training in order to like be able to generate like the sound of like the professor talking through AI. And yeah, let me just like play this. This is like
This is a shorter one.
Yeah.
Hi, I'm Robin. I'm someone who's always been curious about how things work.
Right. I have other demo clips, but you'll see it later. Basically, we also experiment with different state-of-the-art image and video-based methods for generating, videos from a given input. Yeah.
I'm Robin. I'm someone who's always been curious
So we
about
experiment
how
with
things
different kind of methods. For
Whether it's
example, this
people,
one's the image and
systems, or
audio
stories.
methods. As you can see, the echo mimic one that you just saw wasn't very great. This is a Halo one that was released recently, and it does pretty well. We also tried with more methods on the next slide. Yeah, so this is a video to audio methods where we pass in a short clip of the input data and the audio that we want to generate with.
On a massive scale, all of a sudden. The university had a lot of capabilities in this area already. We were already.
So yeah, the
using,
video is completely
tools
generated
like
in this
Slack
case
and Teams
from our
and
input.
Zoom in a limited fashion. We already had some people that were.
And then this is another video editing method where it does lip sync with the audio over the original input video.
In 2020, as we all know, the world changed out from under us in substantial ways, and we had to learn how to do remote instruction on a massive scale all of a sudden. The university had a lot of capabilities in this area already.
Yeah, so that's, how can we go back? Yeah, so that was the Professor Video Avatar side projects that we're doing. Do you want to explain more about like the background for it? Or no?
I think we'll leave it from there, yeah.
Okay, yeah, and then so some future works are to create an application pipeline that would easily create the new video avatars from a single input. We want to try to improve our TTS training and also refine the video-based methods for better results and process time.
All right. So next up is cognitive city twins. And really, one thing that we started doing is just merging CCT with cognitive city twins. So actually, we're just working bringing all of these components into CyberArk core. Just to give you an overview of what makes CCT different, is CCT really the focus is generating tools to allow us to simulate our cities, allowing for interfacing with real-time data from databases and APIs, and being able to access that data online using modern database systems like CouchDB and MySQL. And we're working across different areas. So our kind of proofs of concept areas is Hollywood, Vinyl District, UCSD, Chula Vista, and others. And I want to just go ahead and jump into letting the students share. So Kausa, why don't you come up and share a little bit about how we're actually using this, not just for cities, but also for regions in archaeology.
I think one of the major focus this year was implementing our cognitive city trends into archaeology. So what we planned on doing was creating a twin city of Tel Dor and using archaeological databases to pull in and make dynamic core samples where it would basically pull in excavation sites where exactly the sites were like where we found the data, and based on this, what the other thing that we did was created interactive core sample data where we would load precise archaeological data and present it in a more accessible manner so that it's easy to understand rather than the Excel databases that we would have. For this, we are also using our CouchDB platform and kind of like creating this dynamic framework for which every core we would have a unique widget. One of the main things I want to focus on with Neil is creating real-time interactive graphs. One of the major things that we have noticed is creating these, using this data to create graphs which are meaningful can sometimes take days. And this is something that we want to do real-time within our Unreal Engine. And we also want to make this a more XR and 3D platform, so we could basically go into the Twin City, explore around, and look at the sample data. So this is a mock-up of my widget where you can basically go look at all the data. It separates each sediment by segments, and then you can basically hover over each segment and it tells you each core segment details, where it could basically tell you OSL sample data, grain sizes, total organic carbons for each like extract of those samples. And it also has a way to show spatial data. So this will basically be adapted for each site that we have, and this will be a framework that we implement. Thank you.
Helen?
Hi everyone, I'm Helen. I'm working on one of the current applications of cognitive city twins. This project involves the W Hotel in Hollywood, and it's a collaboration between Smart City Labs, Resilience Studios, and Qualcomm Institute. So here we're merging real estate with immersive technologies to visualize spatial infrastructure. The idea of spatial infrastructure is to combine physical assets with digital systems in real time to provide a more interactive and dynamic experience for both hotel guests and hotel managers. So this would require integrating data from IoT sensors in the hotel and translating them into an easily accessible interface. For this, we've been using ArcViz Explorer in Unreal Engine, where we migrated the W Hotel's digital assets and created widgets that are tied to them. And you can see that here. So with this tool, we've created a clean menu hierarchy, and that makes it easy to view specific areas of the hotel. For example, you can drop into the lobby and see real-time information such as lighting, occupancy, air quality, Wi-Fi, and even some security features. You can also see the different immersive technologies integrated throughout the hotel in the form of these billboards, LED billboards. And also, thanks to talented artists at Blank Canvas, we have accurate 3D models of the hotel's exterior and interior, which you can see as we're kind of swooping in through the building. We're also using Cesium to generate the surrounding environment with Google Maps imagery. You can see that around this hotel right now. And you'll be able to preview local attractions such as restaurants and venues to get an idea of what is accessible in the hotel's immediate surroundings. The menu also includes a photo gallery of the hotel down here. And our future plans include refining the menu system so that it'll refresh after you enter into the hotel, and it will show more location-specific data. We also plan on having an interactive guest experience feature that lets guests preview VIP packages and other hotel amenities to kind of plan their trip.
All right, so next up, thanks everyone from Climate Games and CCT. Next up is everyone on solar weather. And feel free if the faculty and professors want to come up too.
Hello everyone, my name's Andy. I've been with the lab for around a year now, and this is the solar weather project. Essentially, the motivation behind this project is that currently how solar weather data is represented is through 2D slices of like the solar weather phenomenon. But solar weather data and solar weather phenomenon is 3D by nature. So we were curious if we could create a system that would allow us to view this data in 3D, so it's easier to notice patterns and analyze the data and things like this. I've been working with the lab for around a year now under Professor Jackson and Matthew, who's one of the staff, and we're really excited to show you around. Do you want to?
Hello, I'm Matthew. I work with Dr. Bernie Jackson at UCSD's Astronomy and Astrophysics. I've had the pleasure of taking on an advisory role here and working with this group. Andy, as a team lead, has been doing great. So I'm just going to give you a little background about what solar weather is. So for those that don't know, solar weather is created by the outward expansion of plasma. It then follows the sun's magnetic field lines and is propelled outwards throughout our whole solar system. So what we do here at UCSD is we try to use spacecraft data and IPS, interplanetary scintillation data retrieved from icy Nagoya, and we can extrapolate it outwards and try to predict this many days in advance. Okay, so let's go back. So why we care about this is because these solar storms can create kind of mayhem here on Earth, depending on the size of the events. For a modest case, we're protected by our Earth's magnetosphere. But for an extreme case, it will pierce this magnetosphere and can cause radio communications to fail, even power grids. So we try to predict this so we can prepare for those type of events. But at the very least, we get a beautiful aurora that you'll see over the poles that is created by this solar weather. Yeah, and so I'm going to pass it back to Andy, and he will show you kind of where we started and where we're going.
Thank you. So when we started at least when I joined around a year ago, what we started with was the ability to import space weather data as VDBs, which is a file type that represents 3D version of pixels called voxels. And we were able to render that in 3D using Unreal Engine and the sparse volume texture system that they have. Since then, over the last year, me and the rest of the team have worked on adding features to allow scientists to manipulate that data in various interesting ways, and also import other planetary bodies like planets and other types of space weather data like velocity of these solar flares and things like this. Shown above is the pipeline at the moment. We take IPS raw data, which is in the ASCII format, and then convert it into VDB files using a Python script. Then we import those VDB files into Unreal Engine 5, where we use the sparse volume texture system in order to render it in 3D. And then using a MetaQuest app or your desktop screen, you can view the 3D model in either VR or on 2D on your desktop. Most recently, we've upgraded to 5.6, which has given us some really neat features that we're looking to try out. And is packaging supported in 5.6 yet, or?
It should be.
It should be. Oh, so cross off the last bullet point. That's something to look forward to.
I can say a word or two here. I'm Bernie Jackson. I've made these volumes available for almost 20 years, and it's really great to take a look at the shapes from inside as they engulf Earth, as they really do. And we want to make this available in real time to watch as material comes out from the sun. Thanks.
So hopefully that's a little more fun for scientists to interact with than pictures on a screen. We'll take you through a few of the features that we worked on over the past year. And yeah, so something recent that or something that we've been working over the past year is allowing greater types of data to be imported into the project, and also like how can we interact with this data in interesting ways. What you see on the right is a velocity representation of the solar wind data. Previously, only density was able to be imported, but we adjusted the system in order to also allow for velocity files. Some of the challenges there are that velocity files are much more dense, and also have much higher values in terms of their like raw data. So figuring out how to get the color scales to adjust properly and figure out how to get the representations to not be overblown was something that we worked on throughout the quarter. Additionally, we created many systems to interact with the data, including slicing, which is trimming parts of the data so you can focus on a specific window of it. So you can do that by XYZ, and you can also do that by density, which is shown in the lower left-hand corner. You can see that as we increase the lower bound of the density, it isolates those like higher values in the model. So hopefully that's useful for scientists who are interested in only seeing like these really high intensity events. Additionally, as Matthew mentioned before, I helped manage this team throughout the year, and they've made it really easy on me. So that's always nice. We also really expanded our UI over the last few quarters. So if you notice, lower left-hand corner has much fewer options than the upper right-hand corner. It's starting to get to the point where I think we might need a new tab. But we implemented reset buttons to reset all our settings. We implemented different color scales to help people who might be colorblind or in various ranges. We also added info panels to help scientists who maybe aren't super used to VR and who might benefit from having these tutorials on how to navigate around. We also created something called display actors, we implemented something called display actors in our project from the core project, which are actors that display info panels. So this allows us to essentially give info widgets about what you're seeing on the screen. So that's Earth, that's the sun, et cetera, et cetera. And with all this, this was a whole lot of UI to learn in a very short amount of time. Jeffrey was the one who spearheaded all of this, so credit to him. Unfortunately, he wasn't able to come today. But yeah, he did a lot of work learning all this Unreal UI and layout settings, knowing which settings change for which actors. We have a lot of blueprints blueprints are code block, are code segments, you can think of them, in Unreal Engine. So he did a lot of good work in learning how they all interact and then connecting them all together. And then for future work, we're hoping to add some quality of life improvements, like fixing some sensitivity things, and also optimizing like the look and feel of these UI panels with some nice color schemes and things like that. Another thing that we worked on over this last year was importing more of these like solar bodies into our project. So as you can see, we have models of the planets that we were able to import into the project, and using various Python libraries, we're able to convert them into a format that hopefully will make them easy to work with in the future. Some future work that we're hoping to do is add positioning data to some of these models so that they accurately orbit the sun, and we can see how the solar flares interact with the rest of them. Oh, and yes, most of this was spearheaded by Madhav. He was also someone who worked a lot on the different color scales for those who might be visually impaired in some way. So, yeah. And then, do you want to explain this for me?
So I'm Yuning, and I have done the planet positioning for the solar weather. So as with all the models of the planets imported from the previous slide, I do the position calculation for the given time and date with the given time and date, and place all the planets to the correct position to simulate so that we can see the interactions between the solar weather and all the planets. So currently we only have all the planets and the moons, Venus, Mars, and Earth. And the future work, we may put a lot of other artifacts inside, such as the ISS and other stuff. Yeah.
And this is some of the work that Giovanni's helped out with. And I don't use help lightly. He's been a great team member for this group and moving things along here. This is a multiplayer interaction where you can have multiple users at once. I think it's up to 4, but they can all be inside of the volume at once, and they all have same access to the same features of manipulating the volume. And so this is kind of an idea of, when you're showing these people, they might not be too familiar with the VR controls. Well, they can at least just throw on the headset, and the experienced person can kind of show them everything that is very creative to see. And there was I can't tell you all the Unreal side of things on here, but I think this has created a very good opportunity to launch it. I've seen it on the Dev Cave in the lab, and then I think also the Sun Cave. So this is a big milestone for our group. Thank you.
All right, thank you, Solar Weather Team. Next up is Nanoverse VR Team.
Hi everyone, my name is Shravya. I've been working with Neil for around a year now, and I'm the project lead for Nanoverse VR, which is our version of a digital twin for the Nanoverse scale. And so for our project, we've been working on creating an educational VR simulation in order to teach people about nanotechnology and what the scale really is like at the nanoscale. So you guys have probably heard about nanotechnology before, and we define it as the application of scientific knowledge to engineer systems, enabling the investigation into structures at the nanoscale range, and to manipulate and control matter in such ranges to make use of structure-dependent properties and phenomena at that scale. So it can be pretty hard to visualize just how small nanoparticles can be. For example, if you see in this chart right here, nano devices are even smaller than cells, which are already like really, really small. So it's kind of in between the size of an antibody and a virus. And they're so small, in fact, that you can fit almost a quadrillion nanoparticles on a single penny. So that's just the scale that we're working at. And this is also the scale at which most biology occurs. And so for our Nanoverse project, we're actually I'm gonna show you guys how we're kind of like showing the story of the COVID-19 vaccine. So for Nanoverse, we kind of have two target audiences. The first target audience is more of a general audience. And so this is kind of like an immersive learning environment of this application that'll allow participants to explore nanoscale environments, experience processes at the molecular level, and visualize complex scientific phenomena in an engaging and accessible manner. And so we just want to make people aware of nanotechnology and kind of be able to experience the scale of these nano devices. And the other audience that we want to target is more formal education. So for undergraduate students, Nanoverse can be a really awesome tool for education and just showing people how to actually model these nano devices and things like that. So they can use this application as a modeling tool to help construct other nanocarriers for drug delivery, have a tool for reviewing and assessing course concepts. So projects like this can be integrated into undergraduate courses here at UCSD. And students will then be able to analyze the interactions between molecular structures and nanomaterials using virtual reality simulations to visualize, manipulate, and evaluate biological processes at the molecular level. So we have a lot of students on this team. We have a really diverse range of students and mentors, and everyone's skill sets has really been able to come together and make this project a reality. A huge thank you to Yvonne, Yves, and Neil Smith, who have been really instrumental in guiding us on just creating this project. This was their brainchild, and we are just the people who are here to make it happen. So at the beginning of this project, we were really working on ideation, so making sure that our project is really grounded in reality, while also making it fun and engaging. So here are some storyboards that I drew up at the beginning phases of our project. We split our entire project into 4 levels. So first, users can kind of interact with a nanoengineering lab and learn more about nanotechnology. And in the second level, you're actually creating the COVID-19 vaccine. In the third level, you're delivering that vaccine to a cell. And so the vaccine consists of mRNA inside of a liposome. So you can see that mRNA traveling through the cell, going to the ribosomes, and creating spike proteins. And in level 4, you get to see like the fruits of your labor. So all those spike proteins will then trigger the release of antibodies, and you can see those antibodies swarming through the blood vessels and fighting off COVID-19 viruses. And so we have a very cool trailer.
Welcome to the Nano Engineering Lab. Here we work with materials at a really, really small scale. We measure things with nanometers, which are a billionth of a meter. And this lets us interact with things at the molecular or atomic level. Now that you've learned about nanoparticles, it's time to dive deeper.
Oh no, no. All right, there we go. So now we're just going to talk about all the different levels that we worked on and some of the progress that we made. For level 1, this is the introductory level where you're starting off in a nanoengineering lab. I was working on this alongside Lisa, Julius, and Giovanni. So in this level, users can explore the lab and discover different nanoparticles that relate to biomedical engineering. So you can click on the interactive flask like you've seen in the trailer to observe these scaled up nanoparticles. So you can really appreciate just how they're constructed. And also there's an interactive communicator on the side that provides subtitles for some scripted audio that further explain just what the nanoparticle is, like its size, and also what it's useful for. And in the future, we want to increase user interaction. One really important element of this game is that we want to make it really gamified in order to bring users in and make it fun to experience. And so we want to increase user interaction here by introducing choice-based tasks to increase comprehension. So maybe in the future, users can select which nanoparticle would actually be the best for the task at hand. So this is kind of a demo in VR. We have these very special, very cool glasses that will allow you to see these nanoparticles. Yeah, there you go. That's the tobacco mosaic virus nanoparticle. All right, and I'll hand it off to Serene for level 2.
Thank you, Saravia. As she said, I'm Serene, and I helped work on level 2 along with Giovanni and Sankel. And so what level 2 was vaccine design, and it was based all around this. We wanted users to be able to synthesize the COVID-19 vaccine by gathering all the different chemicals in the lab and mixing it in the lab itself in this VR environment. By doing so, we were able to use different instruments that scientists and researchers regularly use, especially those that created the COVID-19 vaccine, such as the Margaret, which is a really large instrument that facilitates vaccine production and basically creates the COVID vaccine. So we were able to recreate this inside of the level and be able to play it, making the player or the person wearing the VR able to interact with these elements as well. We worked on modeling a few different types of lipids and mRNA to explain how vaccine production works and how different elements interact with each other on the nanoscale, as the whole point is to see all of these small things because we aren't really able to see them as they're so small. And so we have a few future tests of adjusting some of the meshes and a few of the proportions of the lipids to make it as realistic as possible, as accurate as possible, and adding more screens and more interactive elements to this level so that you are actively interacting with and basically playing the researcher that created the COVID-19 vaccines. And there is a clip here. So just in this clip, you're able to see you're walking around the lab, you're able to enter. You can't really leave until you've basically interacted with the machines that are necessary at this level. And you can just kind of see it's this machine right here, and it's working on this and synthesizing the vaccine itself. All right, and I will pass it on.
All right. Hello, my name is Maximiliano Hernandez, and I was one of the people that worked on level 3. So in level 3, users that's when they travel in the ship and they get into the cell and then they break through the cell wall. And that was a really cool aspect of this project, working on the cell wall. Let me play one of the videos. Oh, here's the mRNA going along the spline, and this is we added this into the cell. So you'll see the mRNA flow throughout the cell and go into the different ribosomes, which then produce the spike protein. And yeah, we modeled those, and we were able to make a blueprint that you're able to add as many meshes as you want onto it. So I was able to duplicate it because the mRNA strands in real life are huge. And then yeah, in the level, the users travel in the ship, they engulfed by the cell, and then they see different organelles throughout the cell, and you can see that in this clip. Yeah, here is what it looks like inside the cell. It's kind of foggy and murky, and then there's the cell membrane, and there's different aspects of it. And yeah, then the spike proteins get produced. For the future of this level, we need to texture the mRNA, and we also just need to import some more things for the mRNA as well. And I pass it off to.
Okay, I'll also talk for level 4. Giovanni and Gautier were working on this. So for Immune Wars, which is level 4, this is after you've delivered the vaccine to the cells, and this is when the immune response would then begin. And so after delivering the vaccine and triggering the production of spike proteins, users would then travel through the bloodstream to fight off a COVID-19 infection. And so this is more of a game-based level where you're actually directing antibodies to a cell. So when you hover over it and click on one of the viruses that you see, you can then send antibodies to go and deactivate that virus. So this is kind of a demo of what it would look like inside the bloodstream itself. So you can see like all the cells and everything are at scale around you. And you have like the red blood cells, white blood cells, platelets. And yeah. Okay, that's it for Nanoverse VR. Thank you so much.
Next up is Health VR. And we didn't get to see this video, so I'll just play it really quick. So here you can actually see that when you mouse over the COVID virus, all the antibodies go and they attack it. So this is the work of Gautier. So Health VR, why don't you guys come up next?
Hello, everyone. I hope the presentation has been doing well. I am Danny. I am basically the project lead for Health VR. And unlike all the other projects, this is actually the first time that this has been announced announced as part of the projects that are collaborating with Neil Smith. So just to give you a little teaser, so we're just going to go through a video just immediately right now. Thank you. So I'd like to express the intent of this project because it's a fairly complicated matter just for when we're talking about XR or VR experiences. Because the biggest problem is that not all games are created equal. Not all games consider motion sickness the same way. We have games like Gorilla Tag who don't even consider motion sickness at all. So everything around your field of view is just moving all around. And people are very likely to get motion sick. In some other games, such as Half-Life Alyx, they actually give you options to accommodate for your motion sickness by either allowing you to move with your controllers or by teleporting. But it may still be motion sickness inducing for some individuals who are very sensitive to motion sickness. And then even for Beat Saber in a stationary environment, I mean, even if you are watching a bunch of beat notes come at you, there's a lot of stuff happening in the background, which can still induce motion sickness. And so that is compounded with the fact that there's approximately about 30% of individuals that are very susceptible to motion sickness. And that's a huge problem for adoption or any of the projects that have just been presented today. So the goals of this entire project team is to encourage XR accessibility. We want to encourage people to be more active in XR space. We want to be able to promote the use of XR technologies so that they can provide more tools, such as NanoWorld, or provide an improved educational experience. So that's why we created this entire endeavor. And so we are trying to encourage discomfort in XR experiences to analyze this motion sickness in individuals during when they experience XR experiences. And so we also are trying to look for solutions to allow the 30% that are susceptible to motion sickness to engage in XR. So there is some initial work that has been done, and this was in prior times. And we have initially done an engineering tests with our current scenarios that was shown in the little teaser video. So you can see in this video, we have one of the students interacting with the test environment that we have, and he's just simply rotating his view using the controller. And that's a fairly intensive scenario to be involved with, actually. However, there were much fewer scenarios that were tested. So in this case, so in our previous scenario, we only had the individual move back and forth. That's not really realistic for typical XR experiences, I wouldn't believe. So we've changed that in our current set of scenarios. And there was also no investigation to different types of camera rotation. So that means that there's only smooth rotation, meaning that you could only be able to rotate your camera in a smooth fashion. And snap rotation has been shown to reduce motion sickness. So that's why we've also included that in our scenarios. So in general, just the previous implementation wasn't really too representative of common XR experiences. So that's what we've changed for this progress today. So we would like to present two different fronts on evaluating motion sickness and trying to mitigate motion sickness. One part of it is the GVS device, which I will explain in the next slide. And then we have the VR comfort test environment, which you guys have seen in the teaser. So first, I'd like to describe a little bit more about the GVS device. So this is what it looks like. I have it in hand right here. So GVS corresponds to galvanic vestibular stimulation. All that means is that we're stimulating the part inside your ear that governs your sense of balance. So we've developed a solution to basically mitigate or delay the onset of motion sickness. And so we've made some particular adjustments to our previous setup in the last time we used a laptop, which is a very battery-sucking device for just controlling a small little teeny little device like this. And so we created our own hardware to be able to control it without taking up too much power. And so testing the solution is mandatory because we don't know how well this thing, our solution, can mitigate motion sickness. And even though we've had good trials that it has mitigated motion sickness, we need a way to test it. So here comes the VR comfort test environment. So for this particular VR comfort test environment, we basically have two different things. We have an environment of the digital twin of Atkinson Hall that is used to accommodate users and also present scenarios for individuals. These scenarios are presented in different steps of intensity. So it goes from just looking at a screen, a little panel of an eye chart, to completely moving with your controllers, trying to move around inside Atkinson Hall. And so these interactions are fairly important because they symbolize different aspects of XR interactions. For instance, if you were to play Beat Saber, it's mostly gestures that you make with your hand and also things that appear on the screen. In some other cases, when we are playing shooting games inside VR, you have to track objects, maybe even other players. And so that in and itself could be a trigger for motion sickness. So that's why we had to accommodate a wide array of possible actions inside this environment. So I will showcase a couple of these scenarios that we have right here. But the other thing that we also have is that we also have a website control interface. This is much more for the human study aspect of things. But essentially, we have two different parts. One of them is to allow us to switch between scenarios. And the other is so that we can control our solution, which we have right here. So first, I'll go over the scenario. So for this scenario, this is particularly scenario 2. This is right after you've looked at the eye chart. And for this particular scenario, you can see here that the user is drawing shapes on the whiteboard here. And so this is meant to mimic user interactions with UI interfaces. It's like pressing a button, drawing objects maybe on the whiteboard, or some other interactions that you may have. We also tell the user to erase the things that they've just drawn, perhaps to hide the shame of the inaccuracies of the shapes. But one important thing is that we don't want to make the user pick up these objects because that's the next scenario, which is called pickup. And we've had a number of individuals get motion sick from just picking up objects on the ground. And it's fairly surprising given the wide array of possible symptoms or triggers that someone can actually encounter in VR. And so that is the next scenario, which is pickup. So you can see here they are picking up these objects on the table and then putting the objects that are on the ground onto the table. So these objects will get swapped during the scenario. And so this particular reason is because, yes, there have been some people who have seen motion sickness just from bending down and trying to pick up something they dropped. Next, we have tracking, which is just basically the tracking that people usually attribute to for just looking at an object. We test a different array of different movements. So you can see here that there are different lines that this pomegranate will follow. And we also try to look into how close the object is to the player. Because when you look far away, it's different than when you're seeing an object up close. Your eyes tend to focus into far or closer distances, and that can also induce motion sickness. Next, we have the simple maze. So this simple maze is an actual physical maze. So that means you yourself have to go physically through this virtual maze that we have made inside the room. The line is here just to provide a way to guide the users throughout the maze. We don't want to make users have to try to find the exit, mostly because maybe some users will end up going into one dead end, and then some other users just don't even go there at all. So we want to avoid any any extremities inside while measuring the individual's susceptibility to motion sickness in VR. Next, we have the complex maze. And in this particular one, yes, this is exactly what I've talked about. It's basically moving inside the environment using your controllers. And this is a fairly intensive one because it involves both, basically, you're not moving physically. You're just moving using your controllers. And that has proven to be very, very, it's very, very hard on the mind for motion sickness. So a lot of people tend to get dizzy or get headaches from this. Which is good because we want to be able to test the effectiveness of the device that we have. And then lastly, we have uncontrolled motion, which basically just tests how well the user interacts with movement that is not caused by the user. So sometimes the user gets moved instantaneously or on the sliding motion while they're moving sideways. In some shooter games, you actually have to do this because there's a concept called strafing, and you have to move left and right. In VR, that's not the best experience. And if anyone has tried it, you may as well probably take off the headset right there. So that's why we also test this as well. So just to go over the future work that we have for this entire endeavor. So we plan on adding and introducing new biomarkers into our setup. So that involves things like ECGs, heart rates, body temperatures, and other bodily functions that we plan on measuring. The goal with this is that we can inform developers on the possible triggers of motion sickness just based off human factors, and also be able to adapt the game to individuals depending on these biomarkers that we have right here. Next, we have a motion plugin that we are planning to develop, and this is geared mostly towards developers and also the games and experiences that we have right here. We aim to make this a profiler for allowing developers to see what kind of movements can possibly trigger motion sickness. So say you put on the headset and you try to simulate how the game will operate. The plugin will then be able to tell you, hey, maybe you're moving a little too much, or maybe what you're seeing might be a trigger for motion sickness. And so that's how we want to encourage developers to be a little bit more aware of motion sickness in their games. We also want to incorporate health sensors in this as an additional way to profile their games as well. And then also, we'd also like to finalize the engineering test process because all our scenarios are basically done. So all that's left now it's just to test this device. So that's why we need to finalize the processes that we make for our engineering tests so that we can evaluate the effectiveness of our solution. And then lastly, we would like to also move away from this very big block of thing, because it's not the easiest to control, unfortunately. So having our own solution would make it much easier for us to evaluate the solution that we've developed. And lastly, just to make things clear, so if you guys want to experience the motion sickness mitigation, we will be in QI Gallery. It is not in the lab, so you'll have to take a different turn at the very end. But we will be putting on this device on individuals who are interested in trying it, and we look forward to intaking you for the demo. So that is all. That is pretty much it. Thank you.
Thank you, Danny and team. Well, that's it. Thank you all for just coming to the event. Let's just give another round of applause to all the students. One thing I like to do is have the students that are graduating this year stand up. And hopefully those of you that are in the room that are looking to hire talented students, these are the ones to look to. So if you guys have graduated, why don't you go ahead and stand up? And we'll give you a round of applause.